Hello students, this is Meenakshi Rao here. Today I'll be presenting a video for BBA students, University of Mysore, subject Business Statistics 1, meant for 5th semester. The topic for the discussion will be Spearman's rank correlation coefficient. So in this video, I'll be solving a problem on Spearman's rank correlation coefficient with the ties. That is, when there is repeated values in the score. Say for example, A has scored 50, B has also scored 50, E has scored 50. So there are 3 students who have scored 50 marks. In such cases, how to calculate the rank correlation? Let us see that. So when ranks are not given, for the computation of coefficient of rank correlation, while ranking the values, 2 or more values may be equal, and so a situation of tie may arise. In such a case, all those values which are equal are assigned the same average rank. Okay, so we have to assign same average rank to the repeated values, and then the coefficient of rank correlation is found. But you have to make a small changes to the formula. That is, corresponding to each such repeated rank, you have to add a correction factor, that is m cube minus m divided by 12 to summation d square. So correction factor here is m cube minus m divided by 12. So this correction factor needs to be added to summation d square. So the formula will change by adding the correction factor. Now if you see the formula, it remains same, but here we have added the correction factor. So r is equal to 1 minus 6 into summation d square. You should open the bracket and write summation d square plus 1 by 12 into m cube minus m plus 1 by 12 into m cube minus m, and this goes on continuing till where the number is repeated. It will not stop till here. Okay, it will continue. Then divided by n into n square minus 1. So denominator will remain same, but the numerator we should add correction factor to summation d square based on the number of repetition. So d is nothing but it is a difference between the ranks assigned. N is the number of observation and m represent the number of times a rank is repeated. Now let us understand this problem. In a class, 5 students have scored marks in test 1 and test 2, which is depicted in the below table. Find Spearman's rank correlation coefficient. So you have 5 students A, B, C, D, E and score on test 1 and score on test 2. If you see score on test 1, there are 2 students who have scored 17 marks. If you see score on test 2, there are 2 students who have scored 12 marks and there are 2 students who have scored 20 marks. So if they score similar marks, how to assign rank? Simple. You should assign average ranks. You should assign average rank. So how to assign the average rank? We will see in the next slide. So here, if you see the table here, C is the highest scorer and he has scored 18 marks. So we will assign rank 1. Okay, so next highest value is 17, 17. Now both of them have scored same marks, that is A and B. Now we have to assign rank 2 plus rank 3 divided by 2, that is 2.5 for A and 2.5 for B. See, I have written there. Okay, since rank 1 is already assigned, we have to take the average rank. Rank 2 plus rank 3 divided by 2. So 2 plus 3 divided by 2 will be 2.5. So A will get 2.5. B will also be assigned 2.5. Then our next highest is 10. Now while ranking we have stopped with rank 3. Now we have to assign rank 4 for D. Okay, because we have, in the previous step we have stopped with rank 3. Now assign rank 4 for D and rank 5 for E. Okay, in this fashion we are assigning the ranks to score 1. Now let us continue with rank, assigning the rank for test 2. Okay, so this is a table here. So which number is highest here? Yes, 20. 20 is scored by D and D. So there are two students who have scored 20 marks. So rank 1 plus rank 2. So 1 plus 2, that is 3, divided by 2, that is 1.5 for D and 1.5 for E we have to assign. Okay. Now next is, we have stopped with rank 2. Now we have to assign rank 3. Okay, but there are two students again who have scored 12 marks. Now what to do? Rank 3 plus rank 4 divided by 2, that is 3 plus 4, 7 divided by 2 will be 3.5, 3.5. So B and C we will assign. See, I have already written there, 3 plus 4 divided by 2, that is 3.5. We will assign for B and C. Now who is pending? A. So already we have assigned rank 4. Now we have to assign rank 5 for A. Okay, so we have assigned the rank. Now we have to calculate the difference between the rank. That is 2.5 minus 5 will be minus 2.5. In the similar fashion, you have to minus rank 1 and rank 2 for the remaining values. So this will be the values. Okay. Now we have to find D square, that is D into D. Minus 2.5 into minus 2.5, that is 6.25. Similarly, you calculate the remaining D square. So now we have to find the total. So summation D square will be 32. Now we shall find the correction factor. We know that in score 1, okay, 17 is repeated 2 times. So m is equal to 2. So correction factor will be 2 cube minus 2 divided by 12, that is 0.5, which needs to be added to summation D square. In score on test 2, 20 is repeated 2 times. So m is equal to 2. So correction factor will be m cube minus 2 divided by 12, 0.5. Again, 12 is repeated 2 times. M is equal to 2. The correction factor will be 2 cube minus 2 divided by 12, that is equal to 0.5. Now we have to add 0.5, 0.5, 0.5, that is 1.5 to summation D square. We already know that summation D square is 32. N is equal to 5. Okay. So correction factor I have added. See the formula. 6 into summation D square plus 0.5 plus 0.5 plus 0.5. So it becomes 1.5, which you are adding to 32. So it will become how much? 32 plus 1.5 will become 33.5. So 33.5 into 6. So your numerator will be 201. Denominator will be 5 into 25 minus 1. Okay, your denominator now will become 5 into 24. So 201 divided by 120 will give you 0.68. So R is equal to 1 minus 1.68 will give you minus 0.68. Therefore, the Spearman's rank correlation coefficient is minus 0.68. So to conclude, we can say that Spearman's rank correlation can be applied for small samples and when the original data are in form of ranks. So this is the references I have followed.